Good morning, one and all. So today we'll discuss one more problem on a mixed strategy problem. Let us take this problem. Two players A and B plays matching coin game. If coin matches, then A win rupees 1 from B. If coin does not matches, B win rupees 1 from A. Determine the optimum strategy for each player and game value. So here we don't have saddle point. Even if you try to find a saddle point, you will not get the saddle point because this is a mixed strategy problem. So let us see. First one is how to construct a payoff matrix. Then after construction of payoff matrix, we need to determine the optimum strategy for player A and player B. And finally, we need to determine the game value as per the given instruction or as per the given problem. Now let us see the payoff matrix. So it's a payoff matrix. It's a coin matching game. So let us take. There may be chances of getting head and head, or there may be chances of getting tail and tail, or there may be chances of getting head and tail, or there may be chances of getting tail and head. So now, as per this instruction, so this is for player A and this is for player B. And player A, they may get either head or tail, and similarly player B, you may get either head or tail. So now let us see the problem. The two players, A and B, plays a matching coin game. If coin matches, A win rupees 1. See, head and head. If it is matches, A win rupees 1. Similarly, tail and tail. Look at here, tail and tail. If the coin matches tail and tail, player A wins rupees 1 from player B. Okay, um, if coin does not match, B wins rupees 1. So what about A? So always we are writing the payoff matrix for player A, not for player B. If B wins rupees 1, obviously player A he will lose 1 rupee. Therefore, it is minus 1 if coin does not match. So here also, if coin does not match, we will lose 1 rupee. Player A lose 1 rupee. So always I am writing this payoff matrix based on player A, not player B. Okay, so this is the payoff matrix I constructed. So now let us see how to find optimum strategy for these two player A and player B. So before that, I'll calculate, see, 1 minus of minus 1. So that 1 minus of minus 1 is 2. So I'll write in the second row. Similarly, for this one, 1 minus of minus 1. So that is 2. I'll write in the first row. So now go with the vertical column wise. 1 minus of minus 1. So 1 minus of minus 1 is plus 2. I'll write it in the second column. Then go from the bottom side. Now go from the bottom side. 1 minus of minus 1. So that is plus 2. I'll write it in the first column. So I'll repeat. Once again, I'll repeat these things because it's very important for exam point of view. Look at the first row. 1 minus of this value. So we are getting 2. So this 2, I'll write it in the second row. Next, to find this value, I'll go from this side. 1 minus of this value. So that is plus 2. I'll write it in the first row. Then go to column wise. 1 minus of this value. That is 2. I'll write it in the second column. Then to find this value, I'll go from the back end. 1 minus of minus 1. So that is 2. I'll write it in the first column. So now let us see the matrix. So how to find this value? See, this 2 value, this 2 divided by sum of these two. That is a 2 plus 2. So that is equals to, we are getting 2 by 4. That is 1 by 2 means 0.5. Similarly for this one, this 2 divided by sum of these two. So that is 2 divided by sum of these two. That is 2 plus 2 is equals to 0.5. Similarly, go to column wise, this divided by sum of these two. So that is 2 divided by sum of 2 plus 2. 2 plus 2. So we are getting 0.5. Similarly for this one, this value divided by sum of these two. Sum of these two. So that is 2 divided by sum of 2 plus 2. So we are getting 0.5. Okay. So now write down in a statement the optimum strategy. Optimum strategy for uh, player A. Player A can be written as it is player A means row wise 0.5, 0.5, it's a 0.5 and it's a 0.5. Similarly, I'll go to optimum strategy for player B. Optimum strategy for player B, I'll write it as go to column wise. Column wise is 0.5, 0.5, 0.5, 0.5. This is the optimum strategy for player A and player B. So now the next step is we need to determine the gain value for this problem. See, we have one standard formula. Just remember the standard formula to calculate the gain value. So assume it is a 2 by 2 matrix. Remember always mixed strategy problem is applicable only for 2 by 2 matrix. Let us take this term is A11, A12, A21, A22. So gain value is A11 into A22 minus A21 into A12 divided by A11 plus A22 minus A21 plus A12. This is a formula you need to remember to find the gain value in case of mixed strategy problem. So if you apply this formula, so for this matrix, so we're getting 1 into 1 minus 1 into minus 1 divided by 1 plus 1 minus minus 1 plus of minus 1. So we are getting 0. So that is the gain value. So when the gain value is 0, so those games are known as fair game. It's a fair game value because game value is 0. So with this, I'll conclude my today's session. Thank you and thank you so much.